Below the ocean surface exists a nearly boundless environment, which makes up over 70% of our planet's surface. We know very little about this environment and the species which inhabit it. With the invention of the aqualung, scientists began gaining first-hand experience and a better understanding of the shallow regions within only the first 100 feet of the ocean's surface. Within the past 50 years, advanced technology has enabled scientists to begin plunging deeper into this fascinating environment.
How you doing down there? Austin, Jeff?
Roger, roger. We're at the base of the rock rubble here, filming away. We're at 985 feet.
Roger, 985.
Okay, let's...
It is through our direct observations from manned and unmanned submersibles that we become better equipped to understand both the biological and geological processes in this vast, ever-changing environment. Douglas Privet has historically played a key role in the development of manned research submersibles.
Cycle start. Call up our tools. Yeah, about 1957, a guy by the name of Ed Armstrong got me started in making submarines. He had one in his garage, and he called me down one day to help him weld some pieces on it. And I've been working at it ever since, built a whole bunch of them.
For 35 years, Doug Privet has been designing, building, and piloting manned submersibles. This full-scale cardboard mock-up model became the Nekton Alpha, built in 1967-68. After pressure testing to a depth of 1,500 feet at the Port Hueneme Navy testing facility, the Nekton Alpha was ready to begin work down to a depth of 1,000 feet. By 1970, Doug had 3 Nekton subs in his shop: the Alpha, the Beta, and the newly constructed Gamma. These submersibles were used to conduct scientific studies worldwide. The Nekton fleet was primarily built to perform geological studies, which included natural and oil and gas seeps, and the study of the 1969 Santa Barbara oil spill.
This one here is the latest. We got to get this set up here so we can machine the outside of this and drill all these holes.
By 1974, Doug had left Nekton and began planning and building his latest submersible, the Delta. Dr. Richard A. Slater, a former Nekton geologist, had been working with Doug since 1969 as a scientific observer and submersible pilot. In 1982, both Doug and Rich teamed up to produce today's Delta Oceanographics, a worldwide submersible operation performing a full range of scientific studies, marine surveys, and research and development. Combined, both Rich and Doug have piloted over 3,000 submersible dives throughout the world.
So you can't hear them.
Okay, we're at 70 feet coming up.
Okay, here's some models of Delta that were built to scale before the sub was built. We're looking at the front of the pressure chamber here. We're the same thing right here. Here's the port, same port here. And these were pressure tested to destruction. What was the depth on that one? It went to about 3,000 feet, 2,800 feet, 2,882. So all between 2,800 and 3,000 feet when they were destroyed. You notice the ports weren't destroyed, only the pressure holes.
The entire sub was first constructed as individual components, then welded section by section to the main body of the sub. By 1981, Delta was nearly complete.
Yeah, I got to get busy on that. I haven't got one wire.
Located in Torrance, California, Delta's research and development facility is the home for the sub during the winter maintenance and refurbishing schedule. It is a high-tech computer automated machine shop.
This is their CAD/CAM system. We designed the part on this screen here.
Each individual component is designed and given dimension by use of a sophisticated computer program. This system is capable of translating these two-dimensional images into G-codes, readable to a computer-automated machining tool.
So now we're plotting the print that's on the computer system.
This sure beats pencil and paper. And we select the machine in the machine shop that we want to send this program to by turning this switch. The program goes out through a line to the machine in the machine shop, and we put a piece of metal on the machine, and the machine automatically machines the part. This piece of aluminum was used to test out the propeller program. Now we're going to make a real one out of this big chunk of bronze. This device measures the pitch of the propeller. Place this on here like this and bring it down. And that moves over and it gives us a reading here. This is a strobe light we designed and built here. Reflector goes on like this. And we have a plexiglass lens that goes over the outside. This is used for the handheld camera. I'm going to face this thing off a little bit here.
Doug has designed and built 10 similar type submersibles since 1957. Delta's significant improvements over earlier submersibles include better visibility for both pilot and observer, more comfort, and better instrumentation. From its first concept to reality, on December 21, 1982, after 8 years of research, planning, and construction, Delta made her first dive. The sub will spend 2 to 3 months per year in the shop, undergoing routine maintenance and new gear and technology development for the following season's work. Delta Oceanographics business office is located in Channel Islands Harbor, California. Operational planning and scheduling are put into place here before Delta begins its seasonal work in early spring. Delta's overall dimensions are 15.5 feet in length, 6 feet in height, with a 3.5-foot diameter, weighing 5,000 pounds. She has a total of 19 viewing ports. From the pilot's conning tower, a 360-degree horizontal and overhead view is obtained. From the observer's position on the bow of the sub, there's a series of left and right observation ports, plus forward and bottom views.
Yeah.
Delta's electronic motor and instruments operates from a series of batteries which is sealed in its keel. Her top speed is 3.5 knots with a cruising speed of 1.5 knots. Delta is annually certified by the American Bureau of Ships. She has been pressure tested to 1,700 feet and operates down to a maximum depth of 1,200 feet. Delta has made as many as 18 dives in one day, but averages about 5 dives per day, with typical dive durations of 1 to 1.5 hours, requiring as little as a 10-minute surface interval time between dives. Delta has reserves to stay down a total of 144 man-hours. The sub is well equipped for both scientific photography documentation and specialized sampling devices.
All right, on the photographic systems on Delta, we have 4 systems. We have an external television that takes a picture while we're running in front of the sub. We have an external 35mm camera, photo-C camera, that takes 220 pictures at a time. Both these are run from inside, but they're both external cameras. Then we also have a handheld TV inside and a handheld 35mm. The 2 strobes here, this strobe is for the handheld 35mm. This strobe goes with the photo-C for the external. The other black box in here is the Pisces data collector, and it collects things like salinity, temperature, time, depth. All this is encoded on the TV tape inside the sub and can be printed out later in the computer.
We have the Pisces box. This goes in the submarine and brings in the data from the sensor. And it's used also, we use it as our own depth gauge by reading the depth right off here. The next one is the monitor itself, recording all the data. So we go from the box to the monitor. What we do is when we get done with the dive, we pop out the tape. We put the tape, hook it up to the computer. The computer downloads. We take the data off the 8mm video and put it onto the computer, onto a spreadsheet. And what we finally come up with is data such as temperature and depth. And we come up with a graph that shows, in this case, depth over temperature. We also have a hydrolab sensing device. We can also have dissolved oxygen, pH, salinity, and a few others. And that's really nice for the scientists because basically what they have is they have a spreadsheet with latitude, longitude, temperature, depth, and a few other parameters that works really well. It's put on the screen, and we have data that they can manipulate on their own computers, whatever system they have.
David Slater, Rich's son, recalls the beginning of his submersible diving career.
I suppose the first dive I made, and it was Alpha, and I was 11 years old, must have been mid-60s. We were out at Catalina Island. My father took me down to 250 feet. 3 years ago, I was given the opportunity to pilot and been piloting ever since. Don't quite have my father's record of diving, but I'm working on it.
All right, here's a map showing the locations, Delta dive locations, or at least the majority of them. Starting up here in Kotzebue above the Arctic Circle, Russia, Bering.
To date, Delta has logged more than 3,000 dives in various locations around the world, performing geological, biological, and environmental studies and surveys. Rich and Doug first began working in Alaska in 1969 with the Nekton Alpha. In 1987, Delta began performing scientific surveys in Alaska, including geological studies above the Arctic Circle in the Chukchi Sea, chemical oceanography in the Bering Sea, and seafloor transit fish surveys throughout the Gulf of Alaska. In 1989, Delta spent a month diving in the Prince William Sound for the National Marine Fisheries and Environmental Protection Agency, studying the effects of the Valdez oil spill. Delta has also been used to study the mating habits of both the tanner and Alaskan king crabs. In 1991, Delta was contracted by the National Marine Fisheries to study the effects of Alaskan cannery dumping of fish waste on benthic communities.
And it's standing by up here to hear from you guys. Do you want them to stand by?
No, we're writing it negative. They can go ahead and do it.
Delta has been performing a series of fish surveys off the coast of Oregon from 1987 to 1991. Work in this area also includes geological gas seep studies, utilizing specialized sampling devices and instruments.
The Caribbean, we've been working in this area in the Bahamas and Jamaica for about 20 years, mainly geological work, deep work on the walls. Maximum depth was 1110, 1110.
Roger that.
Recent work off the coast of Florida has included research into the environmental impacts of oil exploratory drilling sites and research into sea level fluctuation effects on upper slope regions off the southern Florida Keys.
270 meters of water.
270 meters. All right. Away we go.
Over the camera here.
I'll pull my camera.
What's the dive number? 6'5"?
Yeah, I think it's 6'5". Okay, here we go.
Here we go. 275 meters, you say?
Yeah.
Get away from the ball. In fact, by turning the sub into the waves, I don't get the Oceanographics. We're going down. Yep.
Good.
Well, let's see, the depth is, well, 980 feet. I think we're just about at the outcrop of Portales limestone, which is...
I'm Gene Shin, and I'm with the U.S. Geological Survey, and I've been diving and using scuba for underwater research since the early 50s. It wasn't until the early 70s, however, that I became involved in the use of submersibles for research. I think the first submarine I was in was the forerunner to the Delta. It was one of the early Nekton submarines, and we were using it for collecting rocks on the wall surrounding the Great Bahama Bank. The work we're doing here now off of Key West is to look for old shorelines. About 15,000 years ago, sea level was on the order of a little more than 300 feet, or 120-some meters below present sea level, and we think reefs were forming when sea level was lower, and we've identified some features down here. In fact, the sub's down right now looking at a feature that's either an old shoreline or an old fringing reef. And this would be very important for us, because if we can do radiocarbon dates and uranium, thorium dates on the corals, we can get a better handle on when sea level was at that level, and it's very important today because of the interest in global climate change, which influences sea level fluctuations. Looking at past experience, what I like about the Delta and the Nektons is they're so reliable. You can make 7 or 8 dives in a day very often, which is rare with these other submersibles. And of maybe 100 dives I've made, I've never seen the submarine down for repairs. And I don't think there's any submarine in the business that can make that claim. It was in place, though.
Yeah.
Look at his glasses. Everything fogged up. Oh, that's nice. Ooh, really?
Triple coverage here.
What we're saying is grainstone, no coral.
New England, we've been working up in New England since 1972, 1973. And this has mainly been lobster research, fish, other biological research, all the way from New Jersey up to Maine, even into Canada.
One of the ongoing research projects off New England has been to capture, tag, and then follow a wolffish.
We're going to try an MS-222 this guy, and we thought we'd try it right here since he can't get into his lair. Okay, he's gone. Start cranking. Anything? Yeah, he's getting it right in the face. Oh my goodness. If this guy doesn't get knocked out, nobody's gonna.
These fish have proven difficult to capture, but it isn't for lack of trying.
Okay, we went fast on it before you.
Oh, the hook's right in his face. Oh, bite it. Come on, baby.
Richard Cooper, the director of the National Undersea Research Center at the University of Connecticut.
A number of us back in about 1987 began talking about the importance of extending the knowledge of what we and our cohorts have learned over 25, 30 years of deep sea research, undersea research. Extending this information and the excitement of the whole underwater world to the youth of our country, zeroing in initially on high school age young men and women.
Both students and their teachers participate in the Aquanaut program, gaining valuable insight into the marine ocean sciences. Lance Stewart, the science director of the Undersea Research Center at the University of Connecticut.
The element of bringing this modern technology into the field of oceanography is what the National Undersea Research Program represents. Delta is kind of the key vehicle that we find to be a very useful tool for introductory science and some of our more hardcore scientific studies. It's very versatile. You know, the sub has been proven to be a multiple diving system. We can get many dives in one day. Its sampling is very straightforward.
The Aquanaut program is only one small area where Delta has been utilized by NERP, the National Undersea Research Program. In the past 5 years, Delta has made more than 1,800 dives for NERP off the coasts of Alaska, Oregon, California, New England, the Mid-Atlantic, Florida, and the Bahamas.
We're back.
Good show.
Got a little bit of pressure here. Keep your mouth open.
Do you have a sample? All right.
In 1989 and 1990, Delta was used in Australia and in New Guinea for lobster migration research for the New Guinea and Australian governments, including a gold mine environmental survey at Misima at the end of the Archipelago. Biological and geological surveys were also conducted on the northern half of the Great Barrier Reef.
Slight slope. We're going to be working our way up slope here. It's going to be westerly.
We're on the
bottom. About a 60-degree slope here. 1,100 and must be
20 down.
1,120 feet.
Here's one of those grooves. See how it wears? Just like a stream. See
Yeah.
how smooth it is in the bottom? It takes a long time and a lot of little pieces of sediment to get a groove that deep in. Say hello, Rod.
Hi, Rob.
Good day, Mike.
Hi, mate. There you go. What? One's a Vieto, Richie Didge, and Bon. Hang on. One's a Richie Didge and Roger Mine.
Anybody want to go to America? I'll bet.
Inuitok and Kwajalein. Delta was out there in 85 and 86 working for the Atomic Energy Commission, looking at the bomb craters, mapping the bomb craters in Inuitok and Bikini.
The biggest study we did was in the nuclear bomb craters in Inuitok for the Defense Nuclear Agency. There the depth was just a little too deep for scuba, and there were so many sharks that we decided the submarine was great because the sharks just can't get inside. I think we made something like 265 dives in 9 weeks of diving at Inuitok, and again, we never had a day when the sub was down.
My name's Chris Imes. I'm one of the Delta pilots. Right now the sub's on its way down to practically its maximum diving depth, which is 1,200 feet. And my duties are piloting the sub and just basically getting it ready to go every day and making sure it's safe and operational. The oxygen bottle we use to bleed oxygen into the sub as it's been depleted by your breathing. There's also a CO2 scrubber inside the sub that takes the CO2 out of the air. And we're also removing and adding lead depending on the weight of the pilot and the passengers to control the buoyancy of the sub that way as well. Before the launches, when we're getting ready to launch, we load the sub up, get the passengers on board, and then we have communications between the back deck and the wheelhouse and the sub all at the same time. The sub lets us know if they're already inside, and then the captain will put the ship in the proper position, and then the guy on the back deck will make sure the ship is stopped because it's hard to see the water from the wheelhouse. So you want to make sure that the boat is perfectly stopped and that we have a lee. We're not launching with the wind blowing down on us. The air bottles that we put in, we change after every dive, and they're used for ballast to fill the forward and the rear ballast tanks to allow you to come up after a dive. And in order to go down, you just release that air with the valves on the top of the sub.
Delta uses a mechanical sampling arm, which is pushed out through the hull of the sub to grasp various objects located within the observer's starboard port view. The mechanical arm can also be used to manipulate Delta's suction sampler. The arm can pick up anything from large rocks to small, delicate biological samples. Large objects are placed in a sampling bag, while smaller objects are placed in a numerical collecting cell device.
Here's the track point system for the Delta Submersible. It works in rain or shine. We've had it about 6 years now, and it's an amazing improvement over chasing a tethered buoy on the surface. It's an active sonar. Basically what it does is send a signal down to the submarine receives it and sends it back. And that time delay, it calculates the distance from the ship. We can input the depth ourselves, or if we're in a certain cone of range, it will take over the depth reading for us. It reads out the bearing, the horizontal distance, how far from the sub, and the depth.
Okay, we got the fix.
Voice communication is maintained between the sub and the ship by use of an underwater transmitting phone, which has a range of about 1 mile. Delta has both visual and audio sonar systems, which are used to assist in underwater searches and use in some scientific research.
We're very proud of our safety record with Delta. With nearly 3,000 dives, we've never had any problem, but we do have some safety features we can point out. There's 5 different ways to bring the sub to the surface. We can put air in the forward ballast tank here. We can put air in the rear ballast tank. We can power the sub to the surface. We can drop this lead weight, 180-pound lead weight can be dropped. And we can drop the tail section off back here. If anything would get tangled up, it's removable and we can drop it off. And all the dives we've ever done, we've never had to use any of these emergency systems. We just use the air in the ballast tanks.
Delta is used on ships of opportunity. In the past, it has been used on ships ranging from 60 to 160 feet. Almost any vessel with a crane and a low freeboard can be used.
While they hook us up, and I think we're going to lift us here real quick. Okay. Like such. All right.
Delta and its support equipment, including its self-contained lab, can be shipped anywhere in the world, by ship, air, or truck.